Okay, so we're going to do proof by induction. Sorry, I'm not able to be there with you. I'm just going to do as much work as I can, hopefully while I can. And so proof by induction is a hard concept to get into your head. Okay, so we have this following question. Now, do you see this thing here? This means the sum of. So that means you're going to be adding a bunch of numbers together. Okay, and see the n equals 1. It means you start off with n equals 1, and then it means that you end with n. So in a way, the top part is the that's the yellow part's the end, blue part's the start, right? And this part here, the 2n, is your formula. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, dot 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 dot. And then at the very end, you're going to do, let's say 2 times, before n there's n minus 1. So it's going to be 2 times n minus 1, which is 2n minus 2. And then n at the end is going to be just 2 times n. So you can see that's like t1, that's t2, that's t3, that's tn minus 1, and that's tn. So that's your full sequence, alright? So essentially, these two things are the same thing. This part here and this part here are the same thing. And what I want us to prove is that if I was just to get rid of this part here, I want us to prove that the sum is the same as the formula on the right hand side. So let's get rid of this part because I've proven what that actually means for us. Okay, and it wants us to prove that this sum will equal n times n plus 1. So let me give you an example. Okay, see the way T2 is, T2 would be 2 plus, sorry, S2 would be 2 plus 4, which is 6. Well, if I substitute 2 into this formula, I'm going to get 2 multiplied with 2 plus 1, which is 2 times 3, which is also 6. So what they want us to prove that this formula actually works for any number. So if I did a S3, S3 is 2 plus 4, which is 6, 6 plus 6 is 12, and if I substitute 3 into this formula, 3 times 3 plus 1, or 3 times 4, that will also equal 12. So we've proved the formula works, but we need to prove that the formula works for every situation, okay? And this is called proof by induction. So we're going to start off with the proof by induction now, okay? So here's our proof. You always start off with test n equals 1. Okay, so left hand side is 2. Right hand side is going to be 1 multiplied by 1 plus 1. 2 equals 2. So left hand side equals right hand side, and you say true for n equals 1. Okay, so that means you've proved it for n equals 1. Next step after you test n1 is to assume true for n equals k. So assume true for n equals k. And what you basically do is you sub in, you replace any n values with k values. So you're just going to say 2 plus 4 plus 6 plus 8 plus dot 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 plus 2k. That will equal k times k plus 1. Okay. Now, next one we're going to do is try and do, we're now going to try k plus 1. So we're going to test k plus 1. Test n equals k plus 1. Now, when we talk about the left side here, okay, that's T1, T2, T3, T4, and this is a TK. All right, and this over this side is SK. Now remember what we said earlier that sorry, let's say for example's sake, S3 is T1 plus T2 plus t3. And S4 would be t1 plus t2 plus t3 plus t4. In the same way, S4 can be expressed as S3 plus an additional t4. In this respect, t of k plus 1 can be assumed to be tk, I mean s of k plus 1. So s of k plus 1 can be assumed to be sk plus t of k plus 1. In the same way, S4 can be assumed to be S3 plus T4. Okay, so bear that in mind when we do this. Okay, so now we're going to test n equals k plus 1. So it's going to be 2 plus 4 plus 6 plus 8 plus dot dot dot. Now we're going to have our tk here. That's still there. But we're also going to have tk plus 1. And tk plus 1 is, remember what we said earlier, it's 2 times whatever your term is. So tn is 2 by n. So tk plus 1 will be 2 times k plus 1, which is 2k plus 2. Or quite simply 2 multiplied by k plus 1. Whatever you want, alright? Now, sk is no more. What we're looking for now is s of k plus 1. In the same way, this formula here gives you Sn. So we're looking for s of k plus 1 now. So it's going to replace the n's with k plus 1. So it's going to be k plus 1. And then it's going to be k plus 1, which is k plus 2. So k plus 1 multiplied by k plus 2. Okay, now here's the trick with this type of question, alright? You're going to use the previous steps. So step 1 was test n equals 1. Step 2 was assume true for n equals k. And step 3 was test n equals k plus 1. You're always going to reuse step 2 into step 3. And I'll show you how that's going to happen. You replace all of this part here. And we know what that equals. That equals this part here. So what we can say is that k times k plus 1 is the purple part. I'll just factorize that back out again. Plus 2 into k plus 1 must equal k plus 1 plus k plus 2. Okay? Now, we're going to factorize this back out again, and you can see that this factorizes into k plus 1 into k plus 2. You can see they have a common factor there. And what we've proved there, that it's true we've assumed that this now balances for k plus 1. Alright? So, therefore, true for n equals k plus 1. Okay? Now, true for n equals k plus 1. Okay? Now, here's the true for n equals k plus 1 if n equals k is true. So you're assuming that that part 2 was true. Now here's where the fun kicks in, alright? So what you're going to say is we prove true, so k equals 1 is true, because we proved in step 1 that n equals 1 is true. Therefore, n equals 1 is true. Okay. Therefore, if I want k equals 1 is true, and this means therefore k equals 2 is true, because if k equals 1 is true, and I'll just put k equals 1, this means n equals 2 is true as well. Okay, so therefore n equals 2 is true, and then therefore n equals 3 for 5 dot 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 is true. Hence, by the principle of mathematical induction, it's true for all n element n. True for all natural numbers, because remember, you start off with n equals 1 and you keep going on forever. Okay, so that's question 1 done. You can see there's a lot of fancy language to it, so that can be quite difficult. Please use that language at the end. The language at the end is very important. Okay, I'm not going to do them all. This is quite a costly question time wise. Okay, so we're going to try another one now. No, it will just rub it down. Okay, now let's try another one. So we can always try, I suppose question 3 would be a good one to have a look at as well. Okay, so we'll group copy that, and then we got question 3. So once again, we're going to find the left hand side as this is the left hand side. Okay, this part here is the right hand side. Now remember, this tells you all the individual terms. That tells you T1, T2, T3, T4, Tn. This formula here on the right side gives you Sn. Okay, so as an example, let's go for S3. S3 would be 3 over 3, 3 here, 3 here. So 1 times 4 times 5, S3 is 20. And S3 is equal to T1 plus T2 plus T3. Okay, and what we get there is 2 plus 6 plus 12, which is also 20. So you can see that this is just the Sn formula, and that's the individual, and the Tn formula is Tn equals n into n plus 1. So that's all A-OK. So here's what we're going to do next. We're going to do our 3 steps, alright? So test n equals 1. So we're going to test n equals 1. So on the left hand side you have T1, which is equal to 2. On the right hand side you're going to have S1, which equals it's going to be 1 over 3, 1 plus 1 plus 1 plus 2. And what we're going to have is 1 over 3 multiplied by 2 plus 3. And 2 equals 2. And then you say true for n equals 1. Okay? So that's true for n equals 1. And I'm just going to shrink this. My plan is to shrink this down. Control group, move it all up and shrink it down. Right? So that's our first step up there. Okay, and this is question 5. That's our first question there. Okay, now one second. Okay, so let's keep going. Alright, so that's what we have there. Yep. So we've done test n equals 1 has been done already, and now we are going to do the next part then. Alright, so let's begin. We're going to assume true for n equals k. So assume true for n equals k. such that 1 times 2 plus 2 times 3 plus 3 times 4 plus 4 times 5. Now you're not going to have Tn this time. This was Tn. It's not Tn anymore. It's going to be Tk. So plus 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 Tk, which is k times k plus 1. And we're going to assume that that equals Sk, which is k over 3 into k plus 1 by k plus 2. Alright, next, so that's step 2. Step 3, test n equals k plus 1. So we write down the same thing again, 1 times 2 plus 2 times 3 plus 3 times 4 dot 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 dot, and then we're going to have this is, remember, you're going to have tk, you're going to have tk plus 1, and that all equals s of k plus 1. You don't have to write what I'm writing now, I'm just trying to explain what's going on. That's t1 plus t2 dot 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 plus tk plus 1 equals s of k plus 1. Okay, so that's what I'm trying to explain there. Okay, so what we're looking at here is the following. We're looking at that's k times k plus 1, and that's tk, and then we're going to replace k with k plus 1, so it's going to be k plus 1. So I'm replacing k with k plus 1, so it's going to be k plus 1, which is k plus 2. Alright, and on the other side it used to be sk, now it's going to be sk plus 1. Replace all k's with k plus 1s. And then that's going to be k plus 1, which is k plus 2, and this one is k plus 3. Sorry, I'm running out of space there. Now remember what I said in the last question, we always use step 2 to answer step 3. So if we underline all of this part here, which is all the way up to here, that's T1 all the way up to TK, which is essentially SK, and SK is this part here that I've just after underlining. So what we're going to say here is that this equals k over 3 into k plus 1 by k plus 2 plus k plus 1 k plus 2. So we're going to move all this to the right, and that equals k plus 1 for 3 times k plus 2 times k plus 3. So once again, just to rehash this, that's SK, this is TK plus 1, and that equals S of K plus 1. Sorry, what we discussed in question 1, it's like me saying S3 plus S4 equals, sorry, S3 plus T4 equals S4. Okay, that's basically it, where S3 is T1, T2, T3. It's the equivalent of saying that, right? Now you don't have to write down any of this. This is just me telling you what's actually going on. Now here's what you're going to do next. You're going to factorize this, and what are we going to get when we factorize the two of these? Yeah, sorry guys, I forgot the k plus k over 3 k plus 1 k plus 2. Yep, that's that one there. Okay, so what we're going to do here is we're going to give them a common denominator. Okay, so here's the trick. If I put a 3 here and a 3 here, everything has a common denominator. Okay, and here's what we're going to say. Technically speaking, we can take out 1/3. Okay. We can also take out k plus 1 and k plus 2 out of every single one. So if you're factorising the two of these, the k plus 1 and the k plus 2 are gone, and the 3 on the bottom is gone. And then what's left over? Here's your k, and there's your plus 3. I know that's an advanced move that will take an experienced eye to see, but there it is. Okay, and then that equals, you can take that 1/3 out there, and you say that's 1/3 k plus 1, k plus 2, k plus 3. Okay, and what we're going to say is it's true for n equals k plus 1 if n equals k is true. Since n equals 1 is true, this means k equals 1 is true, and then k equals 2 is true, dot dot dot. Okay, therefore by the principle of mathematical induction, so if you imagine this, alright, k is true, k equals 1 is true, and this means n equals k plus 1 is also true, so this means that n equals 2 is true. And if n equals 2 is true, then I can say k equals 2 is true, and then I can say n equals k plus 1, which is n equals 3, will also be true. So that's the principle of mathematical induction in play. It's like a set of dominoes. Then I can say, oh, k equals 3 is true. This means that n equals k plus 1 is also true. That means n equals 4 is true, and it just keeps going on forever. Alright, so that means you're proving it for everything. Alright, so hence the principle of mathematical induction is true for all positive values of n. So it's true for all n element n. N element n means just positive integers, positive whole numbers.